All right, what we're going to do is we're going to look at the difference between horizontal asymptotes, vertical asymptotes, and this RD stands for removable discontinuities. Okay? Now, so let's just go through it, and it's not going to make a whole lot of sense right at first, but the more we do, it'll make more sense. So let's start with number one. If we start with the horizontal asymptotes, that's a video you watched last night. How do you determine a horizontal asymptote? The degrees. All right, so next to that, put degree. You're going to look at your degrees, right? All right. Now, the degree, and if it's a horizontal asymptote, then your equation is always going to be y equals, right? Always. Horizontal line. So, the degrees, if we look at the degrees, we're looking at the exponents up here. All right. So, my degree in the numerator and my degree in the denominator are the same. The rule is, if they're the same, divide the leading coefficients. So, the leading coefficients are 1 and 1. So, 1 over 1 equals 1. So, my horizontal asymptote is 1. I have a horizontal asymptote at y equals 1, meaning I have a horizontal line, and we'll graph it in a second, kind of think about what it looks like. All right? Vertical asymptote are your roots. And where are you looking, in the numerator or denominator? Denominator. All right, so we're only concerned with the denominator. So before we can do that, we're going to factor everything. Come on, work for me. Okay.
We're only doing the denominator.
No, actually, we have to do both. All right. So let's do the numerator and the denominator. Because the numerator is x plus 4, x plus 2. Right? The denominator is,
X minus 6, x plus 5.
how about x minus 3? X plus 2. Right? Negative 3 plus 2 makes negative 1. Negative 3 times 2 makes negative 6. Now, when you're determining a vertical asymptote, you cannot determine the vertical asymptotes until after you make sure it's simplified. Now, the first lesson we did on this, the numerators were all just numbers. 2, 8, 1, negative 2. Okay? But now we have another function in the numerator. So before we can determine the vertical asymptote, we have to see if anything will cancel. So the x plus 2 and the x plus 2 cancels. So really all I'm left with is just this factor in the denominator. So my vertical asymptote is actually at x equals positive 3 when I solve it, right? All right, now, but we still can't have division by 0 here. So your removable discontinuity, remember on the video it showed the little hole? It kind of graphed it and there was a hole. That is wherever the canceled factors are. Okay? So you can have a 0, you can't have a negative 2 here because it creates division by 0. Do you agree? But because it cancels, it doesn't create that whole vertical asymptote. It just creates a hole. Okay? So our removable discontinuity point, or our singularity discontinuity, something like that, is x equals negative 2. Okay?
What if you have to simplify 2 times?
Yeah, what if you have like 2 common factors or whatever those things are?
You add them.
If they totally everything cancels out, then you wouldn't have a hole. Does that make sense?
But what if not?
Like, what if you have
If nothing cancels out,
No, they're talking about 2.
Like, if you have to
Like, we
simplify
have a
it twice.
trinomial, a quadnomial, I don't know.
oh, you just keep simplifying until you're done simplifying, and then you make these decisions.
Is what you, okay.
Yeah. Whenever you're totally done, if you have 2 factors that cancel, then you'd have 2 holes. Does that make sense? If you have 2 factors left over that don't cancel in the denominator, then you have 2, not holes, asymptotes, vertical asymptotes, right?
x equals 3, x equals
Right.
x equals something?
So if we, yeah.
So say x minus 3 cancel out with another x minus 3, it'll be x equals negative 2 and x equals negative 3 for the argument. So they both cancel.
If they both cancel out, if it was an x minus 3,
Then there
He
would
said
be
x
a
plus 4.
hole.
then there wouldn't be any vertical asymptotes. There'd just be holes.
That's what she was asking.
Yeah.
Will it be too low?
Be two holes. If both of those canceled out, we'll look at that in a second, okay? We'll look at that in a minute. Let's finish this up. Now, let's think about what the graph looks like. So if y'all want to sketch this on the back, you can. I'm going to sketch it here so we can see it all at once, okay? But if I was going to sketch number 1, this is number 1, not number 4, it would look like this. I would have a horizontal asymptote, which is right here at y equals 1, so it would look something like that, right? And then I would have a vertical asymptote at x equals 3, so 1, 2, 3, right like that, sort of, right? And I know my graph, when I graph it, it's going to be in quadrant 1, right? And quadrant 3, so it'll be like through here somewhere. Yes? But this is a hole. So because it cancels, it doesn't create a whole asymptote. It's just going to create a hole at -2. So there's actually an open hole right there.
So the line doesn't go all the way.
Right. It's like if you graph it on your calculator, it'll look like a blank spot there.
But when we draw
Okay?
it, we just keep going.
Yeah. But no, you'd put a hole there.
Oh, we're gonna have to draw more.
Yeah.
Okay, and how do we see the two asymptotes? That's I don't get how you have.
We'll look at that in a minute. We'll look at that in a minute. Does this make sense though for right now? All right. This is the horizontal. This is the vertical, and this is a hole. All right. So let's look at number 3 real quick. We'll do the same thing. So number 3, we're determining horizontal asymptote. What do we look at? The degree. All right, which is the powers, right? So are they the same? No.
So you divide by the leading coefficients and you get
No, you only divide the leading coefficients when they're exactly the same. What's the rule when the denominator has a bigger degree?
You know it's not
Is there one, or is it equals 0? When the denominator is bigger, then y equals 0. If the numerator is bigger, then there's not one, right? Okay, but this one is the denominator bigger, so you have a horizontal asymptote at y equals 0. Oops, that's a 0. All right, so that takes care of that. Now, for our vertical asymptote, we got to do what? Factor it. So the numerator factored is 2 times x minus 5, right? Wow. And the denominator factored is x minus 5 times x plus 1. Everybody okay with that? All right, does anything cancel? X minus 5. So that cancels out. So what is my vertical asymptote, though? What's left over, correct? So x equals -1 because it's the opposite. And then where's my hole? X equals 5 because that's where it canceled. Okay? So horizontal asymptote, vertical asymptote, hole. Okay? A removable discontinuity. It means, what does discontinue mean? That there stops there. Okay? So it stops there, it doesn't go through there, but then it'll go on after that. Okay? It's a hole in the graph. All right? Capiche? All right, so on the back, write these rules down. I'm trying to get forward to the next page. Hang on. It's thinking. There it goes. All right. So vertical asymptotes are roots of the denominator. Vertical. Right? But after you reduce. Horizontal asymptotes, you're going to do according to degree, and you're just going to have to memorize those rules. Okay? There's 3 rules. When they're the same, divide the coefficients. When the numerator's bigger, no asymptotes, right? When the denominator's bigger, where is it? Y equals 0. So you got to memorize those 3 rules. Another video. And then a removable discontinuity is whatever factor's canceled, creates the hole. And if you don't have any canceled factors, do you have holes? No. You have what? Everything's what in the denominator? One more time. If you have factors in the denominator, so let's say you have two factors left over in the denominator and they don't cancel, you have two, what kind of asymptotes? Vertical asymptotes. Okay, if nothing cancels, then they remain asymptotes. They only become wholes if they cancel. Capiche?
So if you don't have any holes, what you put? Zero?
None. Don't put zero, put none. If you don't have any holes, put none if it asks about it. Okay?